Welcome back, Calculus. I am really sorry to be away for optimization, but I was subpoenaed to court. I saw a car accident, and so I'm having a fun day. Anyways, I'm going to do just a couple of examples, and we will do another tomorrow, and then we'll talk about whether we're ready for the quest on Wednesday or not so much. So what we did just before the break was to look at optimization in an interval. So if we had some crazy function, let's just make it ridiculous. And I asked you to find the maximum and minimum values in the interval from A to B. So let's say A and B. You can see by my diagram that I would need to consider all those extrema. I would also need to consider potentially the value at B and at A. It looks like with the one that I've drawn that my maximum and my minimum value will both be extrema, but it is possible for some that A and B would be a place of interest. So we would look at the first derivative and see where it's 0 for extrema. But even if we were very confident, we would also look at the function at the places A and B and see their values. We would compare it with the extrema. So let's say we had values x equals x1, x equals x2 as possible extrema. I would look at my function at those two places as well and make a decision as to which was the maximum value, which was the minimum value. Everyone did very well on that question, so let's put it to real life. This optimization question about a carpenter I don't have written down for you on your handout, so I'll let you write it while I try and draw this diagram of a box. A carpenter is building an open box with a square base for holding firewood. The box must have a surface area of 8 meters squared. What dimensions will yield the maximum volume? So let's see how I do here. All right, absolutely atrocious as usual, but you could draw a better one. And what we know is that the bottom is a square, and we have a height as well. It has to have a surface area of 8. And we want to know, I do old school required to find, but you could write whatever you want. I need to know maximum volume. So my thought process is this. If it's volume I want to maximize, it's volume that I need a formula for, that I'm going to find the derivative, that I'm going to find the endpoints for. So volume is the big idea. Volume of this, well, wretched shape would be x squared times h. My problem with that is I have two variables. And if I want to find the derivative and the endpoints, I want a function with one variable. So I'm going to work off to the side here and say, golly, the constraints that I have is that the surface area is 8. So that will allow me to express one variable in terms of the other. So if I know that the surface area of this thing, let me just check, does it have a lid? It does not indicate so, so I don't think so. So we have a bottom and we have 4 sides. Now I'm making the assumption no lid, but it is for firewood, so I think it's a decent assumption. I know that I need that surface area to be 8. This will allow me to express one variable in terms of the other. So I'm going to have 8 equals x squared plus 4xh. I want to get h by itself, so subtracting x squared from both sides, and then dividing by 4x, I have h in terms of x. So now I have my equation, x squared times 8 minus x squared over 4x. So I have one variable in terms of the other. You would do a better job of communicating that to determine h in terms of x. And we are going to maximize the volume. So even if it seems silly, we are going to consider the endpoints, and we are going to consider the extrema. For some word problems, especially in grade 12, some of the endpoints will seem silly, but that's okay. We're going to consider them anyways. Sometimes a company would give you restrictions on how small or large the sides could be, or how expensive they're willing to pay for the amount of wood and whatnot. Our restrictions weren't given to us specifically, but we could assume that this volume would have to be greater than 0, which is rather silly. So we would have to say that x equals 0 is one of the endpoints. The other endpoint is when your h is 0, which will allow us to have a value for x. So 8 subtract x squared over 4x equals 0 will give us the other endpoint, which is when 8 subtract x squared is 0. Or when the value of x is the square root of 8. Negative root 8 doesn't make any sense. So I have two endpoints to consider. My volume when x is 0, and my volume when x is the square root of 8. My extrema is when the derivative of volume, you can't leave. All right, so when the extrema is 0, and we get our maximum and minimum values that way, where we have a turnaround in our function. So the derivative, I'm going to write my function here. Okay. I would tidy that up before I take the derivative myself. I would end up with, I'm going to divide out of an x. I can do that because I'm already considering x equals 0. I would end up with 8x subtract x cubed over 4. The derivative would be 2 subtract 3x squared, and we're good. All right, I want to know if for extrema when that derivative is equal to 0. Almost done. We will get 8/3. Positive and negative square root of 8/3 are our extrema, or places where our extrema occur. The 1 does not make any sense because it's not in the interval. Or does it make sense in terms of a volume problem? So we're going to look at the two endpoints at 0, at root 8, and also at the extrema, root of 8/3. So we're going to type that into our calculators and get values. When the value of x is 0, our volume is going to be 0. When our height is 0, and therefore our x value is root 8, our volume would be 0. So I'm assuming those are our minimum values. Our maximum value is at root 8/3. And if you put that into the equation, you will get about 2.2 for our volume, meters cubed, which is approximately a value of 1.6 meters. So therefore, the maximum volume of approximately 2.2 meters cubed occurs when the base is approximately 1.6 by 1.6 meters. We could figure out the height if we wanted that as well. Second example is on a handout for you so that you don't have to write it out. But we have a commuter train, carries 2,000 passengers daily from a suburb into a large city. The cost to ride the train is $7 per person. So that's at the beginning of the story. 2,000 passengers. Okay, market research shows that 40 fewer people would ride the train for each 10-cent increase in the fare, and 40 more people would ride the train for each 10 cents decrease. If the capacity of the train is 2,600 passengers, I'm just making little notes to myself here, and contracts with the rail employees require that at least 1,600 passengers be carried, what fare would the railway charge to get the largest possible revenue? So in red, I have underlined our restrictions. Restrictions are given to us by the rail employees and the size of the train. So those constraints will give us our endpoints. And the blue tells us what happened at the beginning of the story. The green is what happens when you start changing things. So first of all, the revenue at the beginning of the story, this is how my brain works, that's all I got. The revenue at the beginning of the story was 2,000 times $7. So I know that's how they figured out how much they got. That would be the fare times the number of passengers. Then we're going to change things. So let X represent. What's going to change? Well, what's going to change is the fare. We're going to up the fare by 10 cents or decrease it by 10 cents. So X is the number of, please underline that, 10-cent increases. All right. Therefore, I'm going to jump down to the fare. Therefore, the fare is $7 plus 10 cents times every increase that we decide on. The number of passengers used to be 2,000, but we're going to lose 40 passengers every time you make a single increase. Now, if X is negative, it's going to suggest to us that we reduce the fare and increase the number of people, but only to a certain limit. Okay. This is the big idea of this type of question. So the revenue would be Again, the number of people times the fare, but it's changed. It's 2,000 subtract 40x times the fare, which may go up. In order to find the maximum revenue, which is what this company would like to do, we need to consider the constraints they put on it and the extrema. So I'm going to start, sorry, this microphone keeps pulling my head. I'm going to start by looking at extrema. The order you consider these doesn't matter, but I want to know, where is the derivative 0? So let's find the derivative of this function. Okay, we have a product rule, or you can expand and find the derivative there. It doesn't matter at all. I'm going to use the product rule. So the derivative of the first is negative 40 times the second, exactly the way it is, plus the first times the derivative of the second. And then we'll tidy it up. Plus 200 subtract 4x. Negative 80, negative 8x. I hope we all got to the same place. I'm checking here. All right. For the extrema, I am going to set the derivative equal to 0 to find those maximum and minimum values. And I am going to get a value of negative 10. So that actually means I am going to decrease my price and get more customers. So that could potentially give me the best revenue. I also need to look at my endpoints. This can be silly or trivial or important and a little bit on the tricky side. So our endpoints come from the restraints that were given to us, that you had to have up to 2,600 people total, but you had to have at least 1,600. So our passengers is what was given to us. We had to have 1,600 and 2,600 passengers. And our passengers, we said, was 2,000 subtract 40 passengers for every increase that you have. So I need to find the value of x in those two places, and that will give us our endpoints to consider. First, I'm going to do the 2,600 and negative 40x less than or equal to 600, x less than or equal to negative 15. Check the math. We're good. Okay. The other one is where 2,000 subtract 40x is greater than or equal to 1,600. Negative 400. When you divide by a negative, flip your sign. Okay. There are my two endpoints where x less than or equal to negative 15, less than or equal to 10. So I have and what I need to finish up here with is to check those values. So I want to know the revenue at negative 10 from the extrema, the revenue at negative 15 and at 10 from the endpoints. One of those will give us our maximum value. All right, we're going to type those in. I'm just going to pop the answers I got up here. I have $14,400, $14,300, and $12,800. The decision is easy enough. That will maximize our revenue. So the conclusion to the matter is, therefore, the maximum revenue is $14,400. And this occurs when the fare is, and our fare was 7 plus decimal 10x, and our x is negative 10. So we've actually decreased the fare by $1. So that will happen when the fare is $6. Try some. Page 145. 149 is kind of the geometry. Page 151 would be a few of these maximizing revenue type questions. Anyway, see you tomorrow. Some solutions are clipped to the board, by the way.